Now today we will see, my dear students, that is binary cycle. What is binary cycle? So already I have talked about your reheat cycle. Now I will talk about binary cycle. What is binary cycle? So as the name implies that binary means two. Cycle means cycle. So that means if we use two cycles simultaneously, then it is considered as binary cycle. Okay. So let us see what is happening in binary cycle. So in the binary cycle, basically we have two cycles. So let us consider two cycles. One is Marcari cycle, and that is water vapor cycle. So when these two cycle happen simultaneously, then it is termed as binary cycles. So you will be able to understand how more betterly if I draw the flow diagram. So let me draw the flow diagram. So first I will start with the boiler. So there is a boiler over here, and the output of the boiler, it goes to the turbine. Okay, so this is a simple power cycle. That then from the turbine it goes to the condenser. So in the condenser, what happens? The heat. So in condenser, what happens? The heat rejection happens. Condenser. Okay. So from the condenser, it goes to the pump. It goes to the pump, and from pump it is fed. So this is a Marcari cycle. So Marcari has a temperature, higher cycle temperature than water vapor. So Marcari deals with the higher temperature. So this is the basic cycle that we are talking about. This is the basic cycle: one, two, three, four. Now what happens in the binary cycle in the condenser? In the previous cases, we have seen that in the condenser water, whatever the condenser energy that we are taking out of the energy, what happens in the condenser? In the condenser, the output of the turbine gas or output of the turbine fluid or working fluid from the turbine releases heat. Let me explain elaborately. So, whenever the working fluid is going out of the turbine, it has some energy, and that energy, some amount of that energy has to be loosed so that the cycle is being completed. That is known as heat rejection. Now this heat rejection happens in the condenser. So in the previous cases we have seen the heat rejection, the amount of heat is going to the environment. But what if we use it instead of sending it to the environment? So in the previous cases it goes to the environment. So that means the fluid is coming in, the condensing fluid is coming in, and it is going out, and the energy goes to environment. So instead of sending this energy to the environment, if we utilize it, how? If we if we if we use another cycle using this heat, just like this. So here we will use the water vapor cycle. So in the previous case Marcari cycle is given. So Marcari cycle deals with the higher temperature. That means the condenser temperature will be higher because Marcari cycle deals with the higher temperature. Then the heat rejected by this Marcari cycle is used to run another cycle which is known as water vapor cycle, that we have read still from the first class. Now what happens? Let me draw the diagram. So in the binary cycle, this is the pump. So in the binary cycle, the condenser of the Marcari cycle acts as a boiler of water vapor cycle. Okay, then whatever heat is rejected by the Marcari cycle is used to increase the temperature of water vapor, the temperature of the water, and it is used to convert the water into the vapor so that this cycle runs. That's why two cycles are running simultaneously using one heat input is known as binary cycle. Okay, so we'll do the analysis for binary cycle, and this cycle happens first. That's why it is termed as topping cycle, because it's always in the top portion on the diagrams, and this cycle happens after the topping cycles. That's why it is known as bottoming cycle. Okay, so let me draw the TS diagram of this binary cycle. Okay, so this is the TS diagram. So first I will draw the topping cycle, then I will draw the bottoming cycle. Okay, so what happens in the topping cycle? This is the two pressure lines, just like this, and this heat is rejected, and that heat is utilized in the bottoming cycle, right, as a heat input. This is the bottoming cycle. So this is 1, this is 2, this is 3, this is 4. Okay, so this is 2 to 3. Okay, so if this one is, this is Q2, this one is 1 dash, it is 2 dash, it is 3 dash, it is 4 dash. So it will be 1 dash, it will be 2 dash, it will be 3 dash, it will be 4 dash. So we can say that H2 minus H3 is same as H1 dash minus H4 dash, because this heat, this Q2 heat is the input of this cycle. This is Q3, this one is Q1. Okay, so similarly said, what will be WT? It will be nothing but H1 minus H2. H1, this is WT. So the turbine work output for the topping cycle, this is the topping cycle because it is on the top of this TS diagram, and this cycle is bottoming cycle. Bottoming cycle. So this is for mercury, this is for water vapor. Now in this case, what we will do, we will find out the efficiency. So let us consider the efficiency of this cycle is eta 1, and efficiency of this cycle is eta 2, and the overall efficiency of binary cycle, overall efficiency of binary cycle is eta. Let us consider this. So what will happen? So eta is nothing but 1 minus our heat rejected Q3 by Q1, right? This is eta. Okay, fine. Now we will find out what is Q3. So what is eta 2? Eta 2 is nothing but, sorry, eta 1. Eta 1 is nothing but 1 minus Q2 by Q1. Okay, so 1 minus eta 1 is nothing but Q2 by Q1. So Q2 is nothing but 1 minus eta 1 into Q1. What is eta 2? Eta 2 is nothing but 1 minus Q2 by Q3. So Q2 by q3 is nothing but 1 minus eta 2. So what is q2? Q2 is 1 minus eta 2 into q3. Oh sorry, q3 by q2, sorry, q3 by q2. So q2 is, one second, it will be q3 by q2, one second, q3 by q2. So what is q2? What is q3? Q3 is nothing but 1 minus eta 2 into q2. Okay, so from the binary cycle we are seeing that eta 2, from the eta 2 is nothing but 1 minus q3 by q2, and q3 by q2 is nothing but 1 minus eta 2. So q3 is coming 1 minus eta 2 multiplied by q2. So what is q3? So the q3, if we see the diagram, so q3, look at over there, q3 will come 1 minus eta 2 into q2, and q2 we have got like this. So it is nothing but 1 minus eta 2 into 1 minus eta 1 into q1. Okay, so if you put it on this equation, eta will come 1 minus q3 by q1 is equal to 1 minus eta 2 multiplied by 1 minus eta 1 into q1 by q1. So it will cut down. So eta is coming 1 minus eta 2 into 1 minus eta 1, or 1 minus eta 1, 1 minus eta 2. So if there are n number of cycles, so what will happen? So it will be 1 minus eta 1, 1 minus eta 2, 1 minus eta 3, right? So it will add like this. Okay, so what is 1 minus eta? 1 minus eta is nothing but 1 minus eta 1 multiplied by 1 minus eta 2, right? So we can write it for n number of cycle, n number of cycle. So if n number of cycle is there, so 1 minus eta is equal to 1 minus eta 1, 1 minus eta 2, 1 minus eta 3 up to 1 minus eta n. So this will happen, this will add simultaneously. If I am taking 5, so this will be up to 5. So this is the way to find out the efficiency of a binary cycle. So if you are asked to do the calculation of binary cycle, so always you will see, always you have to keep in mind one thing, that the heat rejection in the topping cycle will be straightly fed into the heat given to the bottoming cycle. So if there are one more cycle, then it will be intermediate cycle. So if there are one more cycle like this, so this will be then intermediate cycle, and this will be your bottoming cycle. Okay, this will be the intermediate cycle, this will be the bottoming cycle, just like whatever I have written over here. So if the n number of cycle is given, then their efficiency will be like this. So this is not 1, so your efficiency will be like this. So this is the way to find out the efficiency of a binary cycle. Okay, so thank you.